Hi there. Now in this video what I want to do is show you how we can take an algebraic fraction, say something like this, and by using the binomial expansion rewrite it as a series in ascending powers of x. And to demonstrate this we've got this example where we've got to express 5x minus 1 all divided by 2 minus x times 1 plus x in ascending powers of x up to the term in x squared, and state the range of values for x for which it is valid. So the first thing I'd want to do is we'll just copy that fraction down, and we need to re-express this in terms of partial fractions. Now I'm assuming that you're familiar with partial fractions. If not, do go back and have a look at my tutorials on this. But I'm going to go quickly through this stage because it does take quite a while otherwise. Expressing this in partial fractions, because these are two linear factors in the denominator, it's going to give rise to partial fractions of this kind of form where a and b are constants. And in order to find out what a and b are, we multiply both sides by the denominator here. So if you do that, you'll end up with 5x minus 1 being identical to a times 1 plus x plus b times 2 minus x. Now if you've watched tutorials on this in the past, you'll know that we choose appropriate values of x to make each of these brackets 0. X equals minus 1, and for this one x equals 2. And if we do that, you get these results. When x is minus 1, you end up with b being equal to minus 2, and when x is 2, you end up with a being equal to 3. So we can then substitute these values into here, and therefore we have got the fraction here expressed in terms of partial fractions. So as I said, if you're unsure of this step here, do go back and have a look at my tutorials on partial fractions. So once we've done that first step of expressing this fraction then in partial fractions, what we do next is to bring up these two denominators up to the top, rewrite them then in another form, and that would be 3 multiplied with 2 minus x all to the power minus 1. And for this term here, this will be minus 2 times 1 plus x all to the power minus 1. Now the next thing we need to do is use the binomial expansion to expand 2 minus x to the power minus 1 and 1 plus x to the power minus 1. And as a brief reminder, we'll be using the binomial expansion formula because the power here is not a positive integer. But remember that if we're to use the formula, we need to make sure we've got a 1 at the start of the bracket. We're okay here on this one, but not on this one here. So to handle that, what we do, okay, if you've looked at the previous tutorials on the binomial expansion, you'll know that we would create a square bracket and pull out the 2, and would have 2 times 1 minus x over 2. And all of this would be to the power minus 1. Okay? The other bracket is fine, so we'll just leave that as it is, 2 times 1 plus x to the power minus 1. Now, when you've got something like this, we need to simplify it further. Let's just put a little blue star over this, okay? And we'll come to this term here. So if we've got 2 times 1 minus x over 2 then, all to the power minus 1, then we can think of this as being 2 to the power minus 1 multiplied with 1 minus x over 2, all to the power minus 1. And 2 to the minus 1, well, that's 1 over 2 to the power 1, a half. So you've got a half multiplied with 1 minus x over 2 to the power minus 1. So for this term here, Multiplying it with 3 is just going to give me 3 times a half, which is going to be 3 over 2, multiplied with 1 minus x over 2, and that's all to the power minus 1. And then we've got this term here, minus 2 times 1 plus x to the power minus 1. So using the binomial expansion formula here, for this bracket here, you can see the a is the minus x over 2. N will be the power minus 1. So expanding that, we'll just put the 3 over 2 at the front here. Let's put up a square bracket here. We're going to have then 1 plus n times a, so that'll be the power minus 1, multiplied with a being minus x over 2. And then it's going to be plus, and then we take the power minus 1, subtract 1 from it, that's minus 2. We'll divide it by 2 factorial, and then multiply it with a all squared, so that's minus x over 2 all squared. And then that's going to carry on, so plus and so on. Let's just square that bracket off there. And then we've got minus 2 times, and we'll have a square bracket here again. And we just expand 1 plus x to the power minus 1. The a is the x. So we're just going to get 1 plus minus 1 then times x. And then we're going to have plus minus 1 times minus 2 times x squared, and that's over 2 factorial. And it's going to be and so on, plus and so on. So just square that bracket off there. So we just need to expand this out and then group up the terms. So this is going to be identical to 3 over 2 times 1, that's 3 over 2. And then for this one here, this is going to be plus x over 2, times it with the 3 over 2 is going to be 3/4 x. For this one, 2 factorial is 2, and that's going to cancel out with this. So we're just left with minus x over 2 all squared, and if you square that, that's going to be plus x squared over 4. Multiply it with the 3 over 2, and you're going to end up with plus 3x squared over 8. And there'll be other terms as well, plus and so on. And then we come to expanding this bracket out, so it's going to be minus 2 times 1, so it's going to be minus 2. And then you've got negative x here, so minus 2 times minus x is going to be plus 2x. And for this term here, again, 2 factorial is going to cancel out with these two terms here. Just leave you with x squared. Minus 2 times x squared is going to give you minus 2x squared. And there'll be other terms and so on. And if we group these terms up, 3 over 2 minus 2 is going to give us minus a half. And then 3/4 x plus 2x is going to be a total of 11/4 x. So we've got 11 over 4 times x. And then finally for the x squared terms, 3/8 x squared minus 2x squared here is going to give us minus 13 over 8, 13/8 x squared, and so on. So there's our series in ascending powers of x then. Now when it comes to working out the validity for this particular expansion, we should be familiar with the fact that whenever we're expanding something that hasn't been raised to a positive integer power, then it's only valid if the x term lies between minus 1 and 1. So for this expansion here, let's just put a little red star over it, okay? When we look at this one, let's look at its validity. It's valid if the x term, which is minus x over 2, okay, minus x over 2, lies between minus 1 and 1. And if we rearrange this, we can see that therefore x must be between -2 and 2. If you're unsure of this idea about validity, do look back at my earlier videos on this. And for the other term here, where we've got the expansion of 1 plus x to the power -1, then looking at what this one's valid for, okay, we'll just put that in, valid. It's valid if x lies between -1 and 1. So we don't have to do anything with that one. So when it comes to looking at both of these ideas here, it's quite handy if we were to draw, say, a number line. If we had our number line here, we can see that this expansion here is only valid when x lies between -2 and 2. So I'll just draw a line across there, okay, with open circles. When we're looking at this one here, it's valid though between -1 and 1. And if I fill that one in, then we're looking at that region in there. And we've got to be able to have a value of x that works for both of these simultaneously. So we're looking for the one that is the smallest interval, the one that's contained within the other interval, if you see what I mean. And that's this one here, between -1 and 1. So therefore we can say that it's valid for x between -1 and 1. Okay, well, I hope that's given you some idea where you can take this example as a typical model for being able to expand a fraction then by first of all splitting it into partial fractions, then using the binomial expansion to finally get a series in ascending powers of x. Okay?